Hey there, AppSec engineers. Welcome to this video series on application security. I'm Ganga, and we'll be talking about input validation in Node.js applications. Specifically, we'll be talking about using request filters for your API endpoints. Did you know that in January 2023, MailChimp suffered a serious social engineering and API abuse incident? Attackers exploited improper input validation in the API access points to access 133 MailChimp accounts, including those of major cryptocurrency clients such as Trezor. Attackers used the compromised data to launch targeted phishing campaigns against cryptocurrency holders, potentially leading to significant financial loss. So, what was the vulnerability? Input validation vulnerabilities occur when an application accepts user input without proper verification or sanitization. In Node.js applications, this commonly manifests in API endpoints that blindly trust incoming data. Think of it like a security checkpoint that waves everyone through without checking their credentials. And why should developers care? Well, you could have data integrity problems where malicious input can corrupt your database. Security breaches like excesses and injection attacks become trivial. And did you know that the average cost of a breach due to injection attacks is somewhere in the realms of $3.5 million? The immediate risks in Node.js applications when you have improper validation are cross-site scripting, SQL or NoSQL injection attacks, parameter pollutions where multiple parameters can override security controls, data type confusion where unexpected data types can cause your application to crash, resource exhaustion where invalid input can consume excessive server resources. Now let's examine a vulnerable Node.js application and see exactly how these work in practice. To do so, let's switch to our hands-on labs. Before we get into the attack section of this lab, let us take a look at the application file and understand where the vulnerability comes from. In this case, you will notice that the endpoint create user is accepting user input without any validation. There is no email format checking, no input sanitization, no type validation, no length restrictions, or any content validation of any sort. This code blindly trusts user input, and it's much like having your front door wide open and hoping only good people will walk in. Let's see how attackers can exploit this. I already have the environment set up. Let's go ahead and demonstrate a couple of attacks. In the first case, we were able to use both the address and the email properties to insert JavaScript. In a real-world application, this could lead to stored XSS attacks if this data is displayed to other users. SQL injection of this data is used in a database query, and potential server-side code execution even. So we understand that this input validation is quite the important piece in your defense strategy. However, we should talk about how we would go about using this in our defense. Before we implement our defenses, let us discuss why using established validation libraries is better than trying to cook up your own versions of input validation. Because the choice always exists between using a homebrew solution using something like regular expressions versus a much more robust solution that could be offered by well-known libraries such as Validator, express-validator, or JOI, etc. You will notice that in the secure version of the application, we're using something called the express-validator, which is a library that is quite well tested. So the reason we're doing something like this is because well-known or well-established validation libraries often contain battle-tested code. Libraries such as express-validator, JOI, and validator are used by millions of applications. And therefore, even if there are security vulnerabilities to be found, they're quickly identified and patched. And they also benefit from the collective experience of the security community building upon top of each other. You also get quite a bit of edge case coverage because they handle complex edge cases that are quite easy to miss if you're trying to build your own custom solutions. For example, did you know that the email address test at the rate of an IPv6 address is still valid but would often be missed by simple regular expression? It is also exceedingly difficult to account for Unicode characters, international formats, and special cases if you're trying to write your own regular expressions. Further, these libraries are optimized for performance and use quite a bit of caching. More importantly, you get the benefits of regular maintenance, regular updates for new attack vectors, consistent validation across your application, well-documented APIs and community support are something that you can expect from well-made libraries. So let's go ahead and see this in practice with our express validator. On immediate comparison, you will see that we have added several layers of validation to each property that we're expecting from the user. To begin with, we have a check if something is an email. In this case, this validates if the email format is according to the correct RFC, in this case RFC 5322. And this checks for proper domain structure, valid special characters, length restrictions, and if any DNS validation. The reason for this is that you're able to protect against email injection attacks, header injections, and even command injections via email. In the password section, we're able to ensure that we're looking for alphanumeric strings and that we have a minimum length that is a deterrent against brute force attacks. We also have a character set restriction, in this case only alphanumeric, thereby we have predictable encoding. On the user type end of things, we have a list of user types to be chosen from. Therefore, we have strict enumeration and we have a required field validation that guards against role escalation attacks, type confusion vulnerabilities, and even unauthorized access attempts. On the address sanitization part of things, we're able to provide HTML entity encoding. We are able to escape any special characters, and white spaces are also normalized. On the zip code end of things, we are choosing from a list of potential or possible zip codes only within the US. This gives geographic validity as well as consistent data structure. With that out of the way, let's go ahead and run the application with the new version of the validator and see how that protects us against the attack vectors that we discussed before. Looks like we have our application up and running again. Let's go ahead and try the attacks that we did before. And there you go. Both attempts were deflected. The first one contained a JavaScript tag, which was found out to be not a valid email address. And the password parameter was supposed to have at least 8 characters, which it did not. In the second attempt, we also had a SQL injection attack, which was deflected because it was not from a valid user type. The key takeaways here are, as always, to never trust user input and to implement validation at every layer. The use of established validation libraries is oftentimes or almost every time a lot easier and a lot better security-wise, as well as performance-wise, rather than using a custom regular expression-based approach. Ensure that you log your validation failures. Therefore, you can use that information to block certain IP addresses or even rate limit them to ensure that you're not facing any denial of service threats. As always, I hope you learned something, and I will see you in the next one.